In this video, we're going to talk about characteristics of solutions. So the different components of solutions, what needs to be true for you to actually have a solution, and so on. So there are a set of properties that you're always going to have when you have a solution. So a solution is always going to have two or more components. You're going to have a solvent and one or more solutes. And the solvent is always going to be the substance that is present in the largest amount. So if you've got two things, whichever one you have more of will be the solvent. The one you have less of will be the solute. If you've got more than two things, again, you're always going to have something that's the majority, and that will always be your solvent, and then everything else will be solutes. Your solution's also going to have a variable composition. That means the amount of solute to solvent can constantly, or you can vary. So whether it's a 25% solution, a 35% solution, 45, whatever, you can change that ratio of solute to solvent. The properties of your solution are going to change as you change those ratios. So if you think about having a glass of sugar water, if you have a teaspoon of sugar in a cup of water versus 10 teaspoons of sugar in a cup of water, the properties of that solution are different. It's going to taste different. The temperature at which it boils is going to be different, and a number of other things. So the dissolved solutes are present as individual particles. So many times the solute is a solid, not always, but many times it is. And when you put it into your solvent, which is typically a liquid, that solid will dissolve and break apart into individual molecules, atoms, or ions. And what particles it breaks into is going to determine a number of properties. And along with those components at the particular level is requirement that it is homogeneous. So the particles are going to be evenly distributed. You're not going to actually know that there is a solute in the solvent just by looking at it. Then the last one is that the solutes remain uniformly distributed. So again, that homogeneous, and it doesn't ever settle. Every part of your solution is going to have the exact same properties and composition. So if you take a sample at the top of your solution, in the middle, at the bottom, wherever, it's going to be the exact same ratio and same properties. So here's some visuals of this. So the first example over here, we have a solid solute and a liquid solvent, which in this case is water. Mix the two together and you have a solution. And in this particular case, and this is just a specific example, the solute is colored, the solvent is clear, and when that colored solute dissolves in the solvent, the solution is also colored. So that's just, like I said, this specific example and not necessarily going to be the case. Sometimes you think of color change as being a chemical reaction. Here we don't really have a color change. It's just being the blue solid is being dissolved in the clear water to give a blue solution. If we think more at the particulate level, so here's our solute, that's solid. Those particles are packed very tightly together. And whether these are molecules or ions, it doesn't matter. In the solvent, we've got the individual water molecules. Put the solute in the solvent and it dissolves and we make our solution. And you can see that all of the solute particles have pulled away from each other and they are intermingled and mixed into the solvent. So here's an example to think about our solutions and their properties. So we want to decide whether each of the following statements about solutions is true or false. So solutions have a variable composition, and we said this is true. So it's one of the properties of a solution, and this is saying that the ratio of solvent to solute can be varied. Second one says for solution formation to occur, the solute and solvent must chemically react with each other. This is false. There is not a chemical reaction occurring when you dissolve one thing in another. It is actually a physical change. Solubility is a physical property. The third one says solutes are present as individual particles, either molecules, atoms, or ions when in solution, and that is true. The last one, a general characteristic of all solutions is the liquid state. That is not true. You can have gases dissolved in a liquid. You can have two solids actually dissolved together. Metal alloys are considered a solution. So it does not have to be all in the liquid state. In this case, we are given two components of a solution, and we want to decide which is the solvent and which is the solute. So remember, the solute is the small component, where the solvent is the bigger components. So we're just looking at quantities. So the first example says we have 5 grams of sodium bromide versus 200 grams of water. So 200 is bigger than 5. So the water is the solvent, and the sodium bromide is the solute. So again, it does not matter what the substance is, it's all about how much of it you have. Second example, 500 grams of silver nitrate versus 1,000 grams of water. So we're, 50 grams of silver nitrate. So we're comparing 50 to 1,000. So again, water is the solvent. And in this case, silver nitrate is the solute. Third example, we have 50 milliliters of water and 100 milliliters of methyl alcohol. So in this case, we have less water than the second component. So the water is the solute, and the methyl alcohol is the solvent. And then in the last example, it says we have 50 milliliters of isopropyl alcohol and 20 milliliters of ethyl alcohol. So 50 is more, so this is our solvent, while the 20 milliliters is the solute.